This is Dennis Sullivan, NiMotion. I'm going to demonstrate a two-axis inspection stage. Both axes, the x-axis on top and the lower axis down below is the y-axis. Both of these axes are in hybrid servo mode. So let's just jump right in. We're going to go into the first axis on address 1 and go into Setup. Click on the Setup. And you see I've got nominal current. This is datasheet values of 1.25 amps for the size 14 motor, and 2 amps peak, 200 full steps per rev. I've got a 1250 line encoder times 4. That's 5,000 counts per revolution, and the lead screw is for each rotation of the motor, we've got 6.35 millimeters of travel. So the lead is 6.35 millimeters. Let's move over quickly to tune and test. Let's look at the current controller. So we're going to give it a reference voltage and see how that current responds, how that motor current responds to that reference voltage. It's not going to move the motor, it's just going to respond. And you'll see how much current and how quickly that current comes up. There it is. Alright, that's looking good. You can see I gave it a reference. That's the lighter colored curve. And then I also have the magenta colored curve. It comes up and hits, comes up to the reference value in 1.5 milliseconds. No overshooting. It's an excellent curve. Turning to the current, to the position controller. Okay, I'm going to make 1 millimeter moves. I'm going to do that in 150 milliseconds, and I'm going to dwell for 50 milliseconds, and I'm going to have multiple strokes. And I'm going to click Start. And you can see that my x-axis is going to come in and back 1 millimeter. These are tuning moves. You can barely see it, but this axis is moving. Alright, I'm going to click Stop, and it's going to capture that value. So it is really looking good. You can see that the current in green pops up, and then it levels off as you get up to the constant velocity arena. It integrates down. And then at the end of the move, it comes right down into position. You can see that it tops off a little bit up here. Don't get concerned by that. If you want to tidy it up a little bit, we can reduce the integral by 0.05 and reduce the integral limit from 12% to 11%. Well, let's just see what that looks like right at the end of the move. I'm going to do the test again. And I'm going to click Stop, and it's capturing that last in and out move. So that's looking pretty good. Comes right back up, and you can see that it's servoed right into position. Now we can work on this another 5 minutes or another 5 hours, but this is going to work. Alright, let's click OK. And I've got everything else set up correctly. I want those phases to align, and we'll say half a second. No external reference. We're in position control mode. You can see speed, torque. We're using the position mode. And I'm going to click OK. Now I'm going to download the setup. Downloading the setup table, that's the motor setup, and let's download the motion program. Now in an earlier demo we delved into the motion program. It's our standard NiAP motion program. We're downloading it. That motion program has handshaking to our C++ NiAP program, which is stored in an Atmega 128 on our Night 3X board. It's buried behind this chassis. Alright, now we're going to power down and power up. And now we're going to move to cool terminals, just a standard communications terminal. let's clear the screen and let's enter some carriage returns, get night AP ready. Let's do a 1 rel 1, that's the first axis, 50. So we're going to make a 50 millimeter move. There it is. And let's make a 1 rel 1 minus 30. So it's going to be back. Good. So let's home it. Let's do a 1 home 1. Alright, it went out and it found a forked sensor out here. There's a forked optical sensor. We've got a flag mounted to the carriage. There's a flag right here. I know you can't see it very well, but it's there. Alright, so actually let's take this out and get a closer look at the flag. It's relevant. I think you can see that here's the flag right here and the fork sensor. You can see a LED on it, shining on it. There it is. Okay. Move this guy back. Lock it down. Alright. Now that I've got that moving, let's turn over to the y-axis. Now the y-axis, I've got it all tuned up, ready to go. Let's disconnect the comm over here, and you can only have one comm thing going at the same time, so we're in. And I've got some good data already set up here, so let's bypass setting and tuning, and let's go right to connecting here again. Might help if I disconnect communications over here. Work offline and then reconnect here. Carriage returns. And let's do a 1 home 2. Okay. So we've got that guy moving. 1 print. Okay. Let's do a 1 print POS is what I really wanted to do. I got a little bit of error there. First time out of the chute when you download a program, you're always going to see that. So let's do a 1 C move 1 2 50 comma 50. Okay. 1 print POS 50 comma 50 or 49. It's close as it can get. It's within the nearest DSP count. And if I do 1 print pause error, looks like I got a little bit of error on the y-axis. That's the base axis. I knew that going into it. I've got some tuning to do on that one, but there it is. Now if I go to 1 C move 1 2 150 comma 150. Okay, that's good. 1 print POS 150 comma 150. 1 print pause error. You can see that I've picked up another 5 counts of error on the on this base axis. We're talking microns here. It's not a big deal. But as a purist, we're going to get that out. We'll get that down to 0 in the next pass. But for now, this is working just fine. Let's go to 1 C move 1 2. That's the first and second axis. 0 comma 0. You can see that my well plate is just riding on top. 1 print POS and 1 print pause error. And there's that error again. In this case we have 21 counts of error. So I got some work to do. Actually, I don't think it's in the tuning. I think it's in the bearings and the adjustment of the alignment of the bearings on the slide. That finishes this demo. Thank you very much.